But now let me show you what we do with that AppDex score, like how this actually manifests into a feature that we can make use of, how the steering works. Imagine you have a branch office that is currently closed. It's 6 a.m. There are no users in the office. This branch location has 3 internet connections. It has an Xfinity Comcast cable connection, it has a UVerse AT&T optical, and it has a Starlink connection. So first of all, there's no users in the office. So there are no flows for us to directly score to figure out what the AppDex is. So the AppExpress will continuously ping every 10 seconds by default across each path to each application that you've identified as monitor and steer, up to 50. 50 is the current max that you can configure for the entire fabric. So you designate 50 critical applications, you set them up, you set them to monitor and steer, and then I'll show you, you apply them to the EdgeConnect. So the EdgeConnect will then poll to each one of those applications across each path that you have configured. So as it polls across these paths, it's taking those scores. It's saying ping 20 milliseconds, another ping 22 milliseconds. It records those measurements, and then at a given interval, it stops and it computes the AppDex score. And that's what you see here. So this sort of background pinging is always occurring. Even once the users come into the office, it will continue to ping and score the measurements. So this is like priming the pump. So the AppExpress creates an ordered list of underlays or an ordered list of paths with the highest AppDex first, sorted to the lowest AppDex score. In this case, UVerse or AT&T got a 98, Comcast got an 89, and Starlink got a 72. This is realistic. This is kind of what you might see on a daily basis with these 3 providers. Now, notice we've also specified a target QoE. I haven't talked about this a whole lot yet, kind of important. For each application, for each application group, we're going to specify a target QoE. It turns out that in most cases, you're going to end up setting this to excellent or good. I'm not sure there's a good reason to set it to fair or best effort, but you tell the system what to look for. I want you to keep searching across all the paths that you have until you find a path that is at least target QoE or better. So we've selected a target QoE here of excellent. That means that's what the system's going to look for with regard to path performance. It wants an excellent or better measurement. And that means it wants a 95 or better. So now the users come into the office. Now the system, AppExpress already knows which breakout label, in this case, it thinks it knows which breakout label is going to perform best for the users when they arrive. So it's 9 a.m., users show up, they start making Zoom calls, they start getting to work. The EdgeConnect watches the connections, it watches the flows, and it builds up a second QoE number. So there are 2 fundamental QoE scores. There's a ping QoE, which is the synthetic transactions that the EdgeConnect is creating to the app across each path. And then on top of that, there's a user QoE. So we ping stuff, get a synthetic score, and then we put users on the path and then score the user flows to create a user QoE score. Ultimately, the user QoE score is what matters. That is that's what the users are really experiencing, and that's what we care about. So in this case, we put the users on the path. They are heading across UVerse to Zoom, and we look at their flows and we see that they have a 97. That's great. That means that AppExpress identified the best path. It put users on that path, and their experience matched what we thought they would get. But now imagine a little time passes. It's 9:50, and the user QoE for our Zoom flows starts to drop. So now here we have we can see that the user QoE has diminished. It's fallen off to a 79. Maybe it fell off because there was an upstream problem with AT&T or some issue in peering between AT&T and the Zoom's provider. Who knows? Point is that user quality of experience diminished. The AppExpress mechanism will see that the user QoE is no longer meeting its target QoE, and it will start all new flows on the next best link. That means in this case, it looks at the list it has and says, oh, look, Xfinity is number 2. It had a score of 89. So they will then start placing new flows onto Xfinity. So this continues, and this process goes on forever. We're pinging all the time. As users create flows, we observe the behaviors that the flows exhibit from a quality of experience standpoint, and move users around in the grand effort of meeting the target QoE. That's the primary goal of the system, is to find a path that meets the target QoE that's configured for the application. Now, what we've been talking about, this thing here, this is local breakout example. There are three we call transports, or three types of paths that we can make use of. We can work on, AppExpress will work on local breakout, so it'll pick which one of these three local breakout paths is performing the best. But it can also do SSE on-ramps, or SSE IPsec tunnels, or Zscaler tunnels, access tunnels, whatever you want to call it. They're all very similar. In each case, in each SSE case, you'll get 2 pops from the SSE at least. If you ever look at how, if you orchestrate Zscaler, or if you do access service orchestration, you'll see that there'll be 2 different IPsec tunnels from each one of your WAN side providers. So you'll have 2 tunnels going through Xfinity to Zscaler Atlanta and Zscaler Dallas. We'll have 2 more tunnels going through our UVerse connection via to Atlanta and Dallas, and then we'll have another pair of tunnels going through Starlink to Atlanta and Dallas. This gives us a total of 6 discrete paths, 6 diverse pathways through which we can travel to get to Zoom. So AppExpress will take whichever one of these is performing the best and use that as the path that it routes users across. So in this case, it would select this path here through Xfinity via Atlanta to get to Zoom with a score of 96. The total number of paths that we can track is 32. So this is 6. You could potentially have up to 32 paths per app on the EdgeConnect. That's unusual that you would have that many, but it is possible. Check this out. So we also support backhaul. The backhaul use case is useful for all kinds of stuff. In this case, we're looking at Zoom, so we're doing protected first mile, or ruggedized first mile on-ramping. This could also be for internal applications. There's a bunch of stuff. The way it works is it looks at the peer priority configured on the EdgeConnect, and it takes the lowest 6 peer priority peers. So it gets the lowest 6 peer priority measurements. So if you have 6 hubs specified in your peer priority configuration in your template, and you have a peer priority 5, 10, 10, 10, 10, and 10, it will take and use all of those, and it will explore across each one of them. So it will figure out, if I'm sitting over here on the left in this EdgeConnect, and I have default routes that I'm learning from all of these guys, it will figure out which one of these has the best path to whichever application that you are looking to optimize. So in this case, it would work out that if I want to go from this EdgeConnect to Zoom, I should take AWS Oregon. I think that's pretty interesting. It ignores admin distance and metric. It just straight up overrides them. It only cares about peer priority. You just have to be aware of the fact that, hey, it is indeed not caring about admin distance or metric. It is making a policy decision based on the performance of the paths themselves.